Alright guys, so what we're going to look at now is how parametric functions work on the calculator. Okay, so we're going to start off with just a really basic equation. We're going to see just kind of how changes to their calculator are going to affect this graph. Alright. So in order to graph this, the first thing I have to do, just like I did for polar, is go to mode. And while we've been on polar before, now we're going to go to this one that says par, which stands for parametric. So now when I go to y equals, again, my equations look a little different. I have x's and y's with a little subscript of a t. So every line, each time there's a line, I have the t next to it. So I'm going to type in this equation I have over here on the left, where it says x1t equals t. And again, I get t by pushing x, just like I did before. Now, because of the mode I'm in, it's going to give me a t instead of an x or a theta. And then that y1 is going to be 2t minus 1. Now, one other thing it tells me is change my window. So I'm going to go to my window, and I'm going to make my t max. Let's see, those two are flipped, actually. I'm sorry, guys. That should be a t min of 0 and a t max of 4, and a t step of 0.1. My x min is -5. My x max is 5. We'll keep the scale the same, and we're going to graph this. Alright, so now what it wants to see is what happens when I change my t min, my t max, and my t step. So let's change a couple of these. Let's change our t min to -5. And when we do that, now I can see more of my graph. Now let's change our t max to 0. Now I see less of my graph. Alright, let's change my t step to 0.01. And if you see, it's still graphing that line, but it's going much, much, much slower. Alright, let's make that t step 2. Didn't even graph my full line. Alright, let's make it 1. Okay, so we can see a couple things it does. Now, to see a better picture of what that t step does, I'm going to use one more equation. Let's do x equals the cosine of t, and y equals the sine of t. And let's see what that does to my graph. And we know that's supposed to be a circle. So let's try this. Let's make my t min 0. Let's make my t max 10. And let's make my t step 0.1 again. Let's see what that does. So now I have that circle. Let's make that t max down to 5. So not quite the whole circle. So if you think about this, okay, in case you guys haven't figured out yet, what that t min and t max are doing is it's graphing a certain amount of that equation. It's only graphing t values starting at 0 and going until 5. Now if you think about this, my mode here is in radians. So I'm only graphing 5 radians. We know a full circle, though, has 2 pi radians. The reason 10 showed it was because 10 was more than 2 pi. We know 2 pi is 6.28. Now let's use that 6.28. Let's make my t step, instead of 0.1, let's make it just 1. Okay, it doesn't quite look like a full circle. Let's make my t step 3. Not even close to a circle. Alright, let's make my t step 0.01. Okay, so as this goes, hopefully you guys can see what the t step does now. So the t step is how often your calculator graphs one of those t values. So the smaller that t step is, the more accurate your graph's going to be, but also the slower it's going to go before it graphs. Okay, the t min, the t max is just how many t values it's graphing. So we need to make sure we graph enough t values to see the entire graph. Alright, now the next thing that we're going to look at is a question about a spider and a fly. I'm going to make this a little bit bigger. So what I'm going to do here is I'm going to graph 2 equations. One of these equations is a spider, and one of these equations is going to be a fly. So I'm going to graph -2 plus t, and I'm going to graph 5 minus 2t. And then this is going to be 1 minus t, and this is going to be 1 plus t. And then it tells me some things about my mode I need to change. So it says, first of all, my mode needs to be in radians, which it is. It needs to be in parametric, but then I also need to change to simultaneous. Now I've been at sequential. What that means is instead of graphing my lines one after the other, it's going to graph them at the same time. So I'll be able to see my lines graph at the same time. Then it gives me some window settings. So my t min is 0, my t max is 5, my t step is 0.05, my x min is -5, x max is 5, my y min is -5, and my y max is 8. So remember, one of these equations is a spider, one of these equations is a fly. We're going to see by looking at this if the spider and the fly are going to intersect. Alright, so as you can see, those lines are crossing, okay, so we'd think that those two paths intersected. Now the only thing here we have to be careful about is the time. Okay, so what I'm going to do is I'm going to slow down my t-step to 0.01 so we can see this a little bit better. You watch as these two lines go, yes they cross, but are they in the same place at the same time? And if we still can't tell by slowing it down, let's trace on these lines and see. So on this bottom line here that's going negative, that would be my that's going to be my spider line here. Whoops, I'm on the wrong graph. Okay. So as I'm tracing here, as I get closer to that intersection, I'm going to change my t-step to be a little bit bigger so I can get there a little faster. Okay, so I get to that intersection, it says on that trace, that intersection is -1, 3. My one equation is there when t equals 1. Now if I switch to my other equation at t equals 1, I'm at a completely different location. I'm at 0, 2. I don't get to that intersection until I'm at t equals 2. So you can see from tracing as well that those two are not in the same place at the same time. Alright, now there's one last application we're going to look at here. And this is going to be the race. Okay, so we're going to watch a turtle and a hare. So again, it's going to give me some information. It says a turtle and a hare are having a race, and it gives you the speeds that they're going. So we're going to figure out who is going to be at certain places at certain time and who's going to win. And we're going to show this on the calculator. So my mode is still parametric and still simultaneous, so I don't need to change that. But I'm going to change my equations to what it has on there, which is 18t plus 15 and 3 and 24t and 5. Now what this is going to do, the top equation, that's going to be the equation for my turtle, because the turtle is going 18 feet a second and has a plus 15 for the head start. The 24t is going to be the equation for my hare, because it's going 24 feet a second. The 3 and the 5, if you notice, those don't have variables, so they're going to be constant. So what this is going to do is it's going to give me two straight lines, and I'm going to be able to watch these two things go. Okay, so what I'm going to do is I'm going to make my time as t. I need to make sure I have enough time to see the whole race. I'll leave it at 0.1 so I can see the whole thing clearly. I'm going to put my x min at 0. Okay, my x max is how far I'm going to have to watch here. So if I want to see, let's say they're racing for 50 feet. Okay, so if I'm going to race for 50 feet, I'm going to make my x max 50. And then my y min and y max has to make sure I cover that 3 and that 5. So 0 to 8 will still cover it. So what we're going to see now are two lines that are going, and we're going to watch these two things race. Remember the first one, okay, the one with the without the head start, sorry, the one with the head start. Okay, it's going to be at the bottom of our screen. That one is going to be my turtle. And then the one that has no head start, that's going to be the top of my screen, is going to be the hare. Alright, and I'm going to slow that down a little bit. Let's make that 0.01. So remember, the end of the screen is 50 feet. So we're going to see which one of those gets to 50 feet first. And you can see it was the bottom one. Okay, so that means that at 50 feet, if that's a 50-foot long race, that turtle's going to win. Alright, now let's see who's going to win at 75 feet. So I'm going to make my window have an X max of 75. And let's see who's going to win at 75 feet. Alright, so the top one that time. So the hare wins at 75 feet. Alright, now the next thing we can do is to figure out who's ahead at 3 seconds. Now in order to do that, we're actually going to do a little bit of algebra. So what I can do, remember the first equation, 18t plus 15, is the equation for my turtle. So if I want to know at 3 seconds what its location is, I'll just plug in 3 for t. So 18 times 3 plus 15 gives me that value. It's going to be at 69 feet. Whereas at 3 seconds, the turtle is going to be at 24 times 3, which is at 72 feet. So we can see at that point the turtle's winning as well. Then the last thing it asks is at what time does the hare overtake the turtle? So I want to know when 24t is greater than 18t plus 5. So I want to know when 24t is greater than 18t plus 5. So I'm going to subtract 18t. Oops, I forgot that's to be a 15. And then to get t by itself, divide by 6. So at any point when t is greater than 15 over 6, which is about 2.5 seconds. So from about 2.5 seconds on, the turtle's going to be winning, or the hare's going to be winning. Okay, so this was just a little bit of a quick activity for you guys to see how parametric functions work on the calculator, how changing your t-mins and maxes and steps are going to change, and also to see how these different components on parametric equations work.